In this video, we're going to discuss the remaining trigonometric functions: tangent, cotangent, secant, and cosecant. In particular, we're going to define those four functions using the unit circle, as well as find all the trigonometric functions of an angle using the unit circle. In order to define the remaining trig functions of any angle theta, we start by quickly reviewing the definition for the sine and cosine of an angle theta given by the unit circle. So if we have an angle theta, like the red angle pictured here, in standard position, then the terminal side of our angle will intersect the unit circle at a particular point. That point will have an x and a y coordinate, like every point in the plane does, and we define the sine of theta to be the y coordinate of that point, and the cosine of theta to be the x coordinate of that point. Once we've established the sine and cosine of theta, we can define the remaining four trig functions using properties that we know they satisfy for acute angles. For example, we know that the tangent of theta for acute angles using right triangle trigonometry is sine of theta divided by cosine of theta. Using the unit circle, we're simply going to define the tangent of theta to be this ratio sine theta divided by cosine theta. Similarly, we're going to define the cotangent of theta to be the cosine of theta divided by the sine of theta. We will define the secant of theta to be 1 divided by the cosine of theta, so the reciprocal of the cosine. And we will define the cosecant of theta to be the reciprocal of sine theta, or 1 over sine theta. Right? These four will be our definitions for these four trig functions. To see an example of how these definitions are used, consider the angle theta shown in standard position here. This angle intersects the unit circle at the point negative square root 3 over 2, comma 1/2. Given that, we'd like to find all 6 of the trigonometric functions of that angle theta. In order to do this, notice that we do not actually need to know what angle theta is. We simply need to know the points of the intersection between the terminal side and the unit circle, which is given to us. We'll start with the sine and cosine of theta because those are the coordinates of this given point. The sine of theta will be the y coordinate of the point, and so sine of theta will be 1/2. The cosine of theta will be the x coordinate of that point, which will be negative square root of 3 over 2. Right, these two are just the coordinates of the point of intersection. The remaining ones are found using the definitions that we just stated. For example, tangent of theta will be the sine divided by the cosine. The sine is 1/2, and the cosine is negative square root of 3 over 2. This we can compute as 1/2 multiplied by negative 2 over square root 3. The 2's will cancel, and so we're left with negative 1 over square root 3. And this will be the value of the tangent function of theta. Cotangent theta will be the reciprocal of this, the cosine, negative square root of 3 over 2, divided by 1/2. We can compute this similarly as negative square root 3 over 2 multiplied by 2 over 1. The 2's will cancel, and we're left with negative square root 3. The secant of theta is 1 over the cosine, so 1 over negative square root of 3 over 2. This will be negative 2 over square root 3. And finally, the cosecant of theta will be 1 over the sine, or 1 over 1/2, which will equal 2. So our 6 trig functions are found by first finding the values of sine and cosine using the coordinates of the point on the unit circle, and the remaining 4 are found using the ratios of involving sine and cosine. For another example using these definitions, let's find all 6 trigonometric functions of the angle theta equals pi over 6 radians. We'll start again with the sine and cosine of pi over 6, both of which we should know. We should already know that sine of pi over 6 is equal to 1/2, And we should know that the cosine of pi over 6 is equal to the square root of 3 over 2. These were values that we were able to determine using special triangles and right triangle trigonometry. The remaining four are now ratios of these two values. Tangent of pi over 6, by definition, is sine of pi over 6 divided by the cosine of pi over 6. Which would be 1/2 divided by the square root of 3 over 2. And this will simplify to 1 over square root 3. So the tangent of pi over 6 is 1 over square root 3. Similarly, we won't go quite as much detail in the remaining ones, but cotangent of pi over 6 will be the sine of pi over, or the cosine of pi over 6 divided by the sine of pi over 6. So this will be the square root of 3 over 2 divided by 1/2. This will be positive square root 3. The secant of pi over 6 will be 1 over the cosine, so 1 over square root 3 over 2, which simplifies to 2 over the square root of 3. And finally, the cosecant of pi over 6 will be 1 over the sine of pi over 6, or 1 over 1/2, which is equal to 2. And so again, by starting with the sine and cosine values for pi over 6, which we should know, we can easily come up with the other four trigonometric functions for this particular angle. For one more example, let's find all 6 trigonometric functions of the angle theta equals 0. We've previously seen how to find the sine and cosine of 0, but to quickly review, we'll start with the unit circle and look at an angle measuring 0 radians, which will have the same initial and terminal side. The point of intersection over here between the terminal side and the unit circle is the point 1, 0. From that, we can conclude that sine of 0 will be the y-coordinate, or 0, and the cosine of 0 will be the x-coordinate, or 1. The remaining trig functions are now ratios of these values. The tangent of theta, tangent of 0 rather, will be the sine of 0 divided by the cosine of 0, which is 0 divided by 1, better known as 0. The cotangent of 0 will be the cosine of 0, which is 1, divided by the sine of 0, which is 0. But this is a problem because we cannot divide by 0. So this is an undefined value. So the cotangent function for the angle 0 radians or 0 degrees is undefined. The secant function, secant of 0, is 1 over the cosine of 0, so 1 over 1, which is equal to 1. And the cosecant of 0 is 1 divided by the sine of 0, or 1 over 0, and this is again undefined. So for angles like 0, whose terminal side lies on either the x or the y axis, there will be some of these remaining trig functions that will be undefined, because the points of intersection on the unit circle and the x and y axes will always have one of their coordinates equal to 0. And whenever we divide by that particular coordinate, we'll always end up with an undefined value.